All right, we are back. Um, so give it a couple minutes here before I get started. See who might be able to join. It's happening. Okay, we'll talk about that in a second. Just let people know I'm live, and I'm gonna go and get started. So let's talk about what we're doing today. So we're gonna continue our journey coding with LLMs and kind of flexing their ability and seeing what we can get into today. Um, Really, the the goal here is to continue to test out building chess using OpenAI. So we're going to go through this process, but we're going to change things up a little bit. So let's talk about where we were and where we're going. I'll close these out just to simplify my stream here. And right. So last week we created this, and remember we had some issues. It kind of moved, kind of didn't. But this is the last step the AI took, and we thought about maybe seeing what we could do with that. Not really a big fan of where we ended, but we got somewhere. As you can see, if I don't know if you guys can tell on the stream, but when I click, it kind of flashes or flutters, and sometimes you get a highlight, sometimes you don't. It's not really what I want. And then also when I'm making a valid move, we're not actually moving the piece. So there's some definite issues here. But last week when we were working, we used a very simple workflow for ChatGPT. Hey, good morning, Pam. How are you? We used a really simple format for iterating with ChatGPT using the chat interface. So I'd come in here, I would ask some questions, I would paste some code, I'd iterate on the process. And there's this very conversational part, but I was copying and pasting things from here back to VS Code, from VS Code back. And while that works, the iterative process just was not very fun for me. We were doing a lot of manual work to get it back and forth. And then if I got errors, I had to come back and paste them in here. And while all of that works, and it certainly, here, actually, let me, let me do this. We'll say, good morning. Uh, Sorry. I get used to this whole like chat thing. But the idea here is that as we iterate on this, that we don't have to keep going back and forth between VS Code to chat, chat to VS Code. So the benefit to this process, what I have here is that all of this is free GPT. But that also means that we're kind of limited on what models we could use at the time, etc. And yeah, I could I, I could pay for an upgrade, or I could pay for Plus and get access to more. But I'm really just kind of interested to see where we can get without that. And so I'm going to take a slightly different approach today to kind of supercharge our development cycle. And with that process, I'm going to kind of see what we can do to get our code updated without having to jump back and forth between different applications. So what that means is that there's a program called Adder. It's written in Python, which I'm a Go fan, but we're going to look at it, and we're going to utilize this tool to help us kind of pair program, but we're going to do it in the terminal. There's some other apps out there like Cursor. There's some plugins you can get for VS Code. There's other things like that, but we're really not going to focus on those at the moment. We're going to kind of utilize Adder here and kind of plug that in. What that does mean is that you can't use quote unquote the free tier of ChatGPT. Instead, you're going to be connecting to the API of GPT, and you're going to be interacting with that. I have some other tools that kind of went that route, and that's fine. And I actually started building this myself. So believe it or not, before I realized Adder existed, um, I started on this project called Code Sandra, which I may revisit. Code Sandra was my name. It's pretty clever, huh? Like Code Sandra. Um, but if I show you real quick what Code Sandra is, um, it's basically really quick. Let me just give you a quick demo of it. Um, I could at any point go run, and I was playing around with Snake, but I could give it a work directory, and in that work directory, I could give it an input file, and then I could give it a prompt. And what I actually built Codesandra to do is it would run against this work directory, read in the input file, and then based on my prompt, answer a question, and then it would provide back a JSON structured object and write that file to disk. So what this was kind of my tool or my representation of something like Adder, where I could write my own data to disk, and I didn't have to go through this like input cycle of pivoting back and forth from ChatGPT. I could write the file in real time, and I may revisit that. But for this current series, I'm not going to dive into that. It's kind of something I'm doing in my own time. But just to kind of give an idea of what that might look like, um, it's pretty straightforward. If I look at the main.go, I built this all myself. You have some input flags, and then I'm using this library called um, actually we can find that over here, um, by Sasha Baranov, called Go OpenAI, and that project right there allows you to connect to OpenAI pretty easily. So we're reading in our secret. Obviously, we don't store secrets in codes, right, guys? Right? We don't do that. So env variables, and give it some default prompting, and then I would use this project to generate code, and we would give it a prompt, which is the input of the prompt, and we would construct a message that gets sent to the API, and then we would look for a structured response. And that structured response is something that I came up with, that is the files. So whatever files are created and their contents and an explanation. And so when I got that structured JSON data back, I would just write that to disk, and then I could execute that code. We can kind of see what that code looked like. And that's how I kind of accomplished this. But as I started writing this project and I started doing some more exploratory work, I kind of changed some of my Google terms and realized that there's actually a project that's complete out there that already kind of does what I want, because I was tired of going back and forth between the two. So we're going to use Adder today, just kind of giving you the the full kind of picture of where I was a week ago, where we ended, what I did in our off time, and where I've kind of gotten to with some of our research. So this is a pretty cool tool. Installation here, you can look at the guide if you want. You can install it with Python. I actually installed mine using Brew. So if you're familiar with Brew on Mac, that's an option as well. But you have this here. And so what is Adder? It's a tool that works with most of your common LLMs. So think we could pivot to Claude at some point, but we're going to stick with OpenAI. And it allows you in the terminal to ask questions about your code and then do code manipulation. And then what's really cool about that is you can actually execute your code and then take that output and put it right back into the prompt and ask questions about it. So we kind of have this recursive iterative process that we can work on the code. So let's see what that looks like. So you have to set up your API keys with OpenAI or Sonnet or whatever LM you choose to use. Actually, right now there is a let me see if I can find it. Oh, the Adder LM leaderboards. So this is pretty interesting. If you look at this, this is from their perspective using their tool, which LLMs are the leaderboards currently. So you can see here like O1 preview, which is Strawberry. That's what everybody's talking about right now. That's pretty high in the list. In fact, it's getting the highest rating possible. I don't know if I have access to that, so we'll kind of see where we go from there. But then we also have Claude 3.5 Sonnet. I've messed with this a little bit throughout the week, and it does a really great job. And then we also have things like GPT 4.0, and then so on and so forth. So we'll just kind of see what we can get access to here. You do have to set up an API for each of the LMs that you use, and there's some environment variables you can set up. And then that allows you to kind of pivot in and out of these different LLMs. But we're just going to get into the tool. We're going to kind of do some exploratory work right out of the gate. So let me get back into our code with AI project. Now that I've kind of given some, you know, precursor stuff. And I did think slightly about switching projects and going to Snake or something like that, just to simplify things. But then as I kind of iterated on this, I think chess is really where we need to be. We really are exposing an area of uh, LLMs where they really has to start cognitively thinking how to piece things together. And again, because I'm using Go and it's a desktop app, it's not as readily easily maybe or as easy to like kind of put together. Like you do see them out there, but you know, so it's a challenge is what I'm saying for the LLM. And so we can kind of really see and flex where we're going to get to. So in this directory, nothing's changed. I know I did create that other branch, came back, took all those changes out. But the big thing here is that um, we're just going to start here. And so we can call adder. Actually, we can look at the help real quick. I've already installed it. If we look at the help, it's got a lot in here. I'm not going to really go through all of these, but you can like create a chat history file. You can keep track of a lot of different things, env files. If you have an env variable, if you don't want to set it up as like a system prompt. Why is that coloring happening? Hold on. Let me just, it's like weird, like coloring overlay that's happening with me right now. I don't know if it's because my glasses is reflecting the light in a certain way or what. I'm just going to ignore it. So here are a couple of the main things. You can supply your Entropic key or OpenAI API key like on the command line. I don't recommend doing that. Set them up an environment variable, create an environment file, whatever it takes. Just don't do it on the command line. There's instructions for that. Which model you're going to use, and then there's some specific like shortcuts. We're just going to use 4.0 today. We'll maybe use Sonnet in a newer video, and then we've got some other options if we want to drop back to some of these older models. In the grand scheme of models, you've kind of got this, you've got time of execution, so how fast it returns tokens, the cost of those tokens, and how well it performs. So for some tasks, you may want to use a 3.5 or 3.5 turbo, like if you're just summarizing like blocks of text. But in other scenarios, when you want like a little bit more, I don't want to say cognitive, but let's say thorough thinking, which is this common problem called like needle in the haystack. You know, if you have a large paragraph and there's a small bit of information you're trying to sleuth through or extract, you know, the newer models do a much better job with that. It's not really cognitive because you got to remember LLMs are prediction engines. They take your input and provide the next token, not even next word, but next part of a word. And then they iteratively keep sending that back into the LM until they get to a stop condition. All right, so we're going to use 4.0 today. And then I think that's it. Oh, then the last setting I'm going to have here is dark mode because my eyes, I don't want them burning because of the arrays of the sun, 1,000 suns. So what do we got to do to run this? I already probably have it in here. So adder, dark mode, 4.0, and that's where we're going to start. And so we go to the directory we're going to be working in. So we're working in our ChatGPT directory. It notices there's not a get ignore file, and it's going to recommend that we should have one because it's going to create some files there that are just pertinent to adder. So I'm going to say yes, go to let it create that. And here we go. So already our experience is a little bit better. Instead of us having to create certain files with certain conditions, adder's already doing that for us. So now I noticed something that was missing, went ahead and fixed it. Now what's cool about adder is it has all these slash commands. So now I'm in a command prompt, which may be unfamiliar to some of you, but it really is kind of a way to it was where I lived my life, right? I mean, that's what we do on the back end side of things, the dark side, so to speak. Yeah, I don't do no pixel pushing here. You won't catch me pushing pixels for the life of me. Um, so you know, yeah, I'm exploring with some LLMs, but and I am doing some pixel pushing through the LLM, but yeah, the back end's where I live. You know, I like seeing data in concurrency, um, and at scale. So all right, so what can we do here? We can do some things. I haven't messed with all these commands, but I have messed with some of them, like ask and add. Code is another one. I haven't done too much with Git yet, but you can commit from here. So one of the things that's kind of built into Adder is the ability to like, let's make some changes. If you like the changes, commit them, right? So what I'm going to do is this add command, and what this add command does is it allows you to add files in your repository. So in this case, I'm going to add main.go, and we're going to go ahead and add that. And so now Adder knows to look at main.go. Now in this file, if you guys remember, um, we split the panel down here and we look, there really was only main.go that we cared about. Assets is here and it's aware of assets, but you're not really doing analysis on assets. So that doesn't really matter. So we're gonna get rid of that. We're gonna come back here. And so now we're gonna ask it, and we'll just say ask, hey, what do you think, like, how does this code look? Do you have any suggestions for change? All right, so here we go. So it's doing its analysis. So what Adder is doing, Adder is the engine built around everything that we're doing. You know, talk about timing. Let me go let my dog out. I'll be right back. I'll let them back in 5 minutes, I'm sure. So Adder, it's not the LM, right? It's all the logic around the LM that allows you to communicate back and forth and get to this place. So if you can see here, it's just telling us the code looks well structured and implements a basic chess game with draggable pieces using the bin library. Well, great. It built this code, so I hope it's his opinion of it. Here are a few suggestions, improvements you might consider: error handling, code organization, performance optimization, user experience, code readability, testing, game features, etc. Right. So I'm going to ask it to draft these changes. And it's going to go through and it's going to make some suggestions. So what's really cool here, it's going to put that output on the screen for us. So we can actually see what it's talking about doing in different locations of the code. So it's saying like, hey, let's load the LSVG, load piece icons, add some error handling, code organization, and it's going to give some suggestions here about what it would do as far as that goes. So consider creating separate files for different functionalities such as board.go. Now remember previously we were kind of in a single, because we were copying and pasting out of ChatGPT, we were in a single file context. We're not in a single file context anymore. We can, with this tool, we can kind of add different files and we can kind of target like, hey, let's look at render.go, let's look at this, let's look at that. And so it's recommending that we break these up, which is really cool. So what I'm going to do is now that we've kind of primed this conversation, I'm just going to tell it to go ahead. This is really cool with Adder. Like you can have a conversation. It can make some suggestions. I think it's like, go ahead. So it's going to go through and it's, as it will kind of, it moves a little fast, but let's look at what it says. It says, let's implement the changes to improve error handling, code organization, and performance optimization. Error handling and load SVG. Main.go, it found load SVG and it's changing the pattern from just an image to an image and an error. And then at main.go, it's making these changes so you can kind of see and iterate through and make a decision. Now, typically, you want to minimize the amount of concurrent changes that you're asking for at the same time, so that you're more targeted in your changes. But what we're doing in this case is we're just saying like, hey, in totality, what changes do we need to make? And then we're making those. And so you can see here, it's going through each of these, it's making the suggestions, etc., etc. These changes improve error handling and return errors, terminate programs, optimized by, etc., etc. The LM did not conform to the edit format. Okay. Huh. I've not ran into one of these yet. What's kind of cool, well, let's just take a brief moment and before I start digging into that too much, is that it does give back feedback on the tokens used and the costs. So you get a pretty good idea of like how each request like affects like overall, like, so this particular request cost me 2 cents. But the overall session so far has been about 5 cents. Now this is all going to be dependent on how much data we put in and how much data we get back. Um, so okay. So we can actually ask it to run, um, go run here. And what's really cool here, we don't see that here, but you would see any errors. So let's see if it, I don't know if, yeah, so if you have output like errors on the screen or debug messages, you can actually put those back into the chat. We're not going to do that. Let me split this pane up for a second. And let me just get status here. Um, what's the history command? I don't really do this from command line. Hold on. Oh, it's get log. That's what I'm looking for. Okay, so these are the changes that I made here, right? So it made changes to the file. Let's do this. Let's draft changes to split main.go into multiple subfiles. Let's say refactor. Let's just say refactor. Oh, let's close this window up here. We don't need this anymore. So you can see more of the data. So to refactor main.go into subfiles, we can organize this code to logical components. Here's a suggested structure: main.go, game.go, board.go, piece.go, and assets.go. Here's how we can handle the refactor. Okay, so I really like this right out of the gate. I like my main.go to be pretty tight, small. If you have a lot going on in main.go, to me, it's an indicator that you've over kind of built or extended your application, and you really should look to minimize that. There's too much logic in your main file. Now, if you're just building like a one-off like script or CLI tool, by all means, but if we can separate things into their individual domains and components, the better. So then we also got a game.go here. This should be primarily the game logic, tying together the visuals of the board and the layout of the board to the actual like logic and functionality. Although this update and draw method isn't really populated. Board.go defines the board. I'm okay with that. And then piece.go, which defines the piece and the valid moves. All right. So, and then we've got assets, which talk about how to load in the actual individual pieces, etc. All right. I'm just going to tell it to go ahead. And it should take in each of these files, make the necessary changes, and then give us some sort of output based on that data. So what it's building right now is main.go. It's reading in main.go, I think, which is a pretty hefty file. So breaking this up means that as we continue to iterate, as we move forward, we're going to have smaller and smaller subsets of changes. Like, so we'll be able to pass less data to the LLM for analysis, get back less data for a response, and we'll actually save ourselves a little bit of change coin along the way. You know, at this point, I've paid for $10 the API months ago and have played around with projects like this, and I've yet to get to $10. So I'm not really worried about the expenses here. I'm probably going to spend less per month with doing something like this than I would with just copying and pasting out of GPT Plus Pro or GPT Plus as an example. Right, so now we're getting into board.go, so it's actually taking those pieces out and it's kind of separating them out into their pieces of concern. I want to start here just because I think this is going to give us a good foundation for how we move forward. There's some things I don't 100% agree with here, but we're going to ignore it for right now. We can kind of come back and talk about the quality of the code. One thing I'd point out with these LLMs is that really an LLM you really need to treat like spell check right now, which is what I mean by that. Well, spell check, is great because I can type out a word, I can misspell something, it's going to squiggly line it, it's going to show me that it's wrong, it's going to give me the opportunity to correct it, right? Now, if I grew up with just spell check, which I did kind of grow up with spell check, but if I grew up not spelling words in school, I wouldn't know how to write as an adult. But because I went through English class, I went through spelling assignments, I went through these other things, I built up a foundation of understanding how to write, so that utilizing an LLM is just supercharging that same experience. And so, I was asked last Friday, I'm going to kind of mention again, should you learn to code? Well, yes, learning to code, you should learn to code just like you would learn to read and write. Could you live your life today with all the technology we have without needing the ability to read? Yeah, if you had like text to voice or something. Could you do it without the ability to write? Yes, you have voice to text. Certainly that could handle all that capability, but without having an underlying layer of what good writing looks like, what good spelling looks like, without all those individual components, um, you're going to really struggle to just try to use LLMs in the future to generate code for you. If it's running into an error, if you don't understand how to debug it, you don't understand how the car works, you're going to have a really hard time. So, even though these LLMs are really going to supercharge our ability to code as we move forward, we still need to be careful of like as relying on them as like the way of the future of the developer and saying that developers aren't going to exist in the future. No, we're going to exist just like content writers exist today, although the LMs might replace them. But uh, you know, the idea is that we're still going to need to be there to kind of maintain that code and understand it. And the fact of the matter is, I heard this the other day. Um, LLMs are designed to generate average code. It's the average of what the populace of the people generate. So it's going to create something that works. It's going to create something that probably gets the job done, but it's going to be at the average, the middle of the ground of what you're really looking for. And so humans will always, at least in the short term, be able to beat out an LLM. We also have to understand that LLMs do not have reasoning. They don't, as much as it feels like they do, they don't. They are token predictors. So they are predicting right here when it is generating this content, it is taking the previous content that was inputted by, let's say, up to this point, feeds that into the LLM, and the LLM then produces the next token, so on and so forth, and so on and so forth, and so on and so forth. Okay, so that was a lot of work. That cost me a total of 8 cents to complete, and we were at 18 cents for the session. I think these facts are pretty cool to look at. But it's asking if we want to create a new file for game.go. It's very polite. There might be a way to turn these off, but I'm just going to leave them on for now. Board.go, piece.go, and assets.go. So now we have multiple files. And if you look here inside of Adder, you can see that they've all been kind of aggregated to the top. So what does this mean for us? Well, since they're aggregated to the top, I can ask Adder a question and it will use any of these files. We'll look through them as necessary and provide the feedback that we're looking for. Now, it looks like it auto committed for us, which is good. And what we're going to do is we're going to run. We're just going to run the program again. Okay, this is a great example of what I like about Adder is that it went ahead and made some changes, but now things are in a broken state, right? This is not good. So we could, in like VS Code, some of these things like undefined strings, etc., might get fixed. But what I'm going to do is I'm just going to put this output back into Adder, and I'm just going to hit yes. That's going to put it back into my chat, right? And Adder's already running with that. It's saying, hey, to resolve the errors, we need to do this, this, this. Let's make these changes. Game.go went ahead and did that. And then it went ahead and made those changes. This is fantastic, in my opinion, because I didn't have to actually run the application, didn't have to create the error, didn't have to copy and paste it into GPT. It already went through that and it said, hey, you want to run this shell command? Yeah, I do want to run this shell command. Okay. Boom. Assets.go, A2 strings import and not used. Let's go ahead and do that. And then I'm going to go ahead and run again. Yes. I don't know what I missed earlier, but okay. So went ahead and fixed it. And I'm going to hit yes. And here we go. We're back running again. 1 second. I got to let my dogs back in. All right. So where are we at? All right. So we're running again. Okay, great. If anybody's curious, I have a hound pit mix that we just call hound mix. So it's just a hound mix. It's important. And a mini golden doodle. Sorry about that. All right. So we're right back where we were. Um, so no errors, but not what we want. So we're kind of where we were Friday, but we've done some refactoring last Friday. So this is what I want. This is what this is what I want. Um, I do not the moving a piece is currently accomplished by clicking and then moving the piece. And I do not like that. I would rather have click and drag functionality. Can you please make this change? All right, cool. See what happens. Right, let's see what it said. To implement click and drag functionality for moving piece, we need to modify the update method in game. The goal is to start dragging a piece when the mouse button is pressed and release it when the mouse button is released. Here's how we can achieve that. So I'm just going to say, go ahead. And that's going to go ahead and implement. And we're going to say, yes, let's run it. Ah, that's beautiful. I'll take that. Okay. Getting there. Great. The pieces are not moving when released. Is this because I'm going to help kind of like lead it a little bit. To diagnose why the pieces are not moving when released, we should check a few key areas. Move validation logic. Move validation logic. Ensure that the isValidMove function is correctly validating. If the logic is too strict or incorrect, it might prevent valid moves. Drag and release logic. Verify that the drag release logic is updated. Let's review the relevant code. The isValidMove function board checks if a move is valid according to chess rules. That each piece specifies moves valid functions, etc. is correctly implemented. Dragging and release. In game.go, the update method handles dragging and releasing. All right. So this is interesting because it's adding some additional debug information in here so that we can run the command instead of just like figuring it out. All right, so I'm just going to say code, please fix these errors. So if you do code, it'll just go ahead and implement whatever you ask. So pretty straightforward. I didn't really have to do much there. You can see it just fixed it. Okay. All right, that's going to be a lot of data, which that's one thing we have to be careful of. I don't want to send all of that to GPT. Instead, I'm going to run again, and I'm just going to do a quick, and then we'll add this. The issue seems to be the move validation logic. Okay, so it was able to tell that we were, that's pretty crazy. So it was able to tell that we were actually like moving the mouse around. It was able to make some positions, but it realized that there was an issue. This issue seems to be the move validation logic. Let's temporarily bypass the is valid move check to see if the piece moves correctly without validation. You can modify the update method in game.go. Went ahead and did it. And then I said, yes, let's go ahead and try it out. Okay, cool. We're gonna say no here, but then I'm gonna say that the piece now moves when I release the mouse, but I can move it anywhere. Move the piece. All right, so we're just going to keep iterating on this and kind of see what happens. It says, now that we know the issue is the validate logic, let's focus on ensuring that the isValidMove function and its related piece validation functions are correct. Pawn movement. Okay, so let's see what it does for pawn movement. This was the temporary bypass. It's putting it back. Okay, so let's do it. I'm gonna tell it to go ahead. And then I'm gonna ask it, I want to try to minimize. I'm gonna have it remove the mouse position because that's gonna blow up our it's gonna blow up our logs, right? And the problem is that if I keep putting what the output back to GPT and it keeps including that, we're going to be sending a ton of data back to GPT. So, you know, as you can see, we're already at like 44 cents this session. It's killing my pockets here. All right, let's run it. Yes. And it's going to fix it. Okay. Well, the LLM is not coming back accurately. So this is interesting. I did not run into this with Sonnet, but I'm running into it with OpenAI's a ChatGPT. So this tells me that obviously some LMs are not working correctly. That's unfortunate. Bad missing file name. Oh, looks like it eventually got it right. Let's see here. Okay. No. Yes. Yes, I know. Please do so. Okay. Awesome. So now we've got some debug message. This is pretty cool because GBT put this in itself. It's telling me it's an invalid move, and we can kind of see why that is. Okay, cool. Um, let's see what it comes up with. Um, I made some valid moves, and it looks like the function is not validating correctly. Can you fix? So it's trying to do all this like validation itself. It's trying to do some of this validation itself, and I feel like that's a bit of a part of the problem. So let me do this. I kind of want to give it a leg up because like I think the idea of coding in all the logic of chess is a bit much, but there are some libraries out there that do work really well. Um, let me do this. So instead of trying to validate the moves yourself, how about we use a library? Can you not nil a great library, a great chess library written in Go. Could we use that to validate our moves? Right. So now we're just going to give it like a leg up. So it's like I'm talking to a junior dev, right? So like, hey, you know what? You're doing a lot of work here. You're trying to validate these moves yourself. I'm really not sure that's actually working for you, but let's just see what we can do here and go from there. For making these okay, let's see what it came up with. Certainly, using a library like Not Nil Chess can simplify move validation by leveraging its built-in chess logic. Here's how we can integrate. Install this. Integrate Not Nil Chess for move validation. Modify your code. Use your library for validating moves. You'll need to update the game struct and include chess.game instance and use to validate the moves. Here's a step-by-step. I'm trying to really validate how well ChatGPT is just going to put stuff together for me, so I'm not going to read through all the code here. We're just going to keep moving. Remove the is valid and is path clear functions as they're no longer needed, etc., etc., etc. I'm just going to tell it to go ahead and see what we come up with here. All right, so let's look at these actual changes here. So let's integrate the not nil. So it added it to game.go, implement the chess game, chess.new_game. Okay, it's initializing it good. It's moving to if g.chess.position.board.piece, chess.square, chess.nopiece. Okay. Remove those functions. Is path clear? Is valid pawn move? Yes. Let's see what we got. Yes. Fix these errors. I'm using code here because I know I just wanted to fix the problem. So let's see here. Okay. So I'm going to help a little bit because this library, chess not nil, by not nil. So if we do Golang not nil chess, it's a good library because it has all the chess logic built in. But what's not, what they don't have is like a new move function, which I think maybe can be implemented in the library. Maybe that's an option for us, just kind of knock out in the future. But the only real way that you can move um, without looking at what moves are available is by implementing this game.move string using is this fen note? Oh no, this is algebraic notation. Using algebraic notation, chess algebraic notation. Um, and so I'm gonna help it out a little bit. And just go with that and say I think the best way to accomplish this is to attempt a move on the chessboard using move string. Yep. Has to convert to algebraic notation. Got it. So the code to use this approach and then give it a shot. Where did all my chess pieces go? Um, it disappeared my pieces. Uh, this is going swimmingly. Absolutely swimmingly. I, here you go, guys. ChatGPT is going to replace the programmer. Like, what? Okay. What do we do now? Here, let's be more firm. That's what we'll do. We'll be more firm. Um, the chess pieces are still not on the board at initialization. At game start. They must be at their starting positions when we start the game. I see. I see. So it thinks for some reason the initial chess game isn't set up correctly with the pieces in their starting positions. I highly doubt that. I think we've gotten so far lost right now that the LM is very confused as to what it is doing. Um, Adder's doing a great job here. I don't. This isn't an adder problem. No piece at. Okay. Cool. 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 Is this really long? Oh yeah. Yeah. It's just blowing up the logs. Okay. 1 second. We're gonna say no, and then we're gonna run this again, and then I'm gonna close it right away, and then I'm gonna say yes. We've lost it. We've lost it. We've got off the deep end. Oh, go ahead with what? That was my bad. Oh no, I've exited Ader. So do star. Can I just add? How do I remove? Um, Drop assets. Aha. I'll drop also go.mod and go.sum because they're not really important for, you want to minimize. What do I want to do? Let's start back here. What happens if I click on a place that doesn't have a piece? Okay, if I click on a place that doesn't have a piece, we're okay. Okay, this is what we're gonna do. We're gonna try to help. We're gonna try to help the LLM. Okay. So if I bring up some VS Code, right, and I look at where the SVGs are loaded, the assets, this is of light for the color and dark for the color, and we have pawn, rook, knight, bishop, etc. And if it can't load the piece, we should have an error, but I don't think that's the problem. I think what we're running into is that load SVG what in the world? I didn't do that, did I? I must have. Oops. What I think is actually happening is that there's an association somewhere that if I run this, there's an association that is linking our asset to our game icons, and I think that is what is failing. And so, where is this called? Load piece icons, right here. Right. So how is piece icons being used? That's my problem. Okay, color. Light dark. Okay, it's got that. But piece dot type. Okay, well, if not nil, do some stuff, else do absolutely nothing. How about we log? What are we doing for other logging in here? Like, what did it choose? Just from the print line? Okay. We're gonna help it out because I can't. I'm waiting too long here, and now what I thought was optimizing my development cycle has actually slowed my development cycle down, right? So we don't want to actually see something that slows us down. So instead, I'm gonna pivot in, and I'm gonna say, hey, this is the problem. And so let's go here. Error received. Error while looking up icon. Actually, error could not find icon. S icon key. Right. Righto. We'll go with that, and then we'll go with that way the hard return is interpreted. All right, now we're just gonna do a little bit of our own here, and we're gonna get rid of this, and then we're gonna come back here, and we're gonna just go and run again. Okay, cool. So what's happening here is that it's trying to load the icons based on a KBP, right? So the LLM can't logic this, right? It can't figure this out. It can't figure out that there is a mapping that it created as dark underscore pawn, right? If you go back to the load SVGs here, the assets, it's creating them as the key name as light underscore rook, but the program is looking for light underscore p. So we're going to say no. And then what I'm going to do is I'm going to say, it looks like the assets file is creating the map as dark. We're going to do some things here. We'll say dark. I'm not going to code it. I can fix it, but I'm not going to. I want the LLM to do it. Say dark underscore underscore, we'll say lights, and we'll say there we go, pawn, knight, etc. But we are trying to load them as, we'll say P, K, Q, B, R, and then we'll put this back. That is why we cannot see icons. See the following example. Error. Okay. So now we're just going to provide this error in as like an option. So I'm going a little bit above and beyond here. Because I'm trying to explain like what the issue is, and then they have to do some sort of like mapping here, right? Okay, so let's go ahead. Let's implement what it's suggesting, and let's kind of see if this fixes the issue. It couldn't reason this. I don't know if it ever would. It has to kind of like know the computation of the two separate maps and see that there's a difference. Maybe next month. Maybe next month. We have pieces back on our board. Look at that. We've accomplished something. That took us only an extra little bit of time. Okay. So our white piece is moving. Our black piece is moving. Okay. interesting. I think uh, also, I noticed playing around with it earlier that it has a hard time cognitively thinking of light as white and dark as black. Um, Whoops. Okay. Say A B C D E F G 0 1 2 3 4 5 6 7 8 9. Um, what or how is a chessboard laid out? So let's lay out the board so that the white pieces are at the bottom. Yeah, okay. So it just had a difference in opinion on perspectives, right? But it's still not working. Okay. So here's my problem with LLMs. Here's the hot take right now is that this is the issue. This is right here the problem with developing is that using GPT 4.0, um, I'm troubleshooting more the understanding of the LLM to understand what I'm asking for and give me the right appropriate output more than if I was just to go ahead and just fix the issue myself. So let's try one thing. Let's try one thing here. Um, I guess to be fair, you could technically be playing as black too. So I mean, but it's okay. Now we're really broken. It's there, guys. It's ready. It's ready for us. All right. What are we gonna do? Um, the chess game is broken. I'm just gonna ask it to fix it. Let's see what happens. So nice that it's linting for me. Yeah, it's so weird. Okay, so I think it's kind of working. Like I can't. Okay, so it's only allowing me to move valid pieces. Like it's kind of working, but it's kind of not. Like it's the controls are inverse from where they should be. So let me no. Um, all right, let me just see if we can fix the. Ah, oh my gosh. Really? Okay, hold on. No, please, please remove the drawing. Okay, well, that's quiet. All right, so I think we're back in business. Back in business. Okay, so our pieces are drawn in the right square. Um, let's see if we can do like a little opening here. Okay, that's good. Okay, let's move your knight out. Oh, okay, that's a little bit of a problem. We're just gonna see what issues we can come up with here. So I know that. Aha. So we can't move knights. So there's something going on with that, and we'll have to figure that out. Let me see if I move. That doesn't work. Oh, because it's black's move. That's why. Okay. So it's the algebraic notation that it has is incorrect. It's basing it off of something. So we can do this. Let's no. Let's say please add a log for each move's algebraic notation. All right, cool. So that right there, what I just did, I consider that helpful if this actually works. Okay, so it's D2 to D4. Okay. Um, I'm not like a huge chess guy, but wouldn't that just be D4? Okay. So why was that C7 to C6? Why wasn't that K C6? Okay. Right. Okay. So now if I try to move way up here, that doesn't work. If I try to move here, that works. Okay, great. That's kind of working. No. Um, please provide a log of the algebraic notation on an invalid move. Okay. Making progress. Let's see what we got. I don't want to baby it this much. I don't want to do it. I went too far up. All right. Okay, D2, D5. Okay, so now we've got that. So let's say I move this here, you move this here, and I move this here. It's a valid move. C1 to G5. Would that be C1? I don't think that's technically right. What would the notation? Does anybody know what chess notation is for moving to bishop? Like, is it just, yeah, it's B, either lowercase or uppercase b to E5, right? Or G5 or whatever it is. So it would be from here to here. So it's not C1, it's BG5 or B H6 or BE4, right? Right. Okay, so but why did it come up with F2, F4? Hmm. Okay. So um here, let's do this. How can we create a sample set? What will we do here to provide like output? So what I'm trying to think about is like, how do I actually get this to iterate on this error? And so, okay, I'm going to do that, and then I'm going to do that, and then I'm going to do that. Okay. So what I'm going to say is yes. The issue is that the algebraic notation for invalid move is being logged incorrectly. The move string variable is being used to represent the attempted move, but it should be constructed using the correct starting in any position. Let's fix that by ensuring the move string is correctly constructed for invalid moves. Here's the search and replace. So what do we change here? I'm kind of interested. Move string is from file from rank to file. Okay, move string equal nil. Just 2, algebraic notation, g.chess moves length, -1 string. What? I don't understand that. What in the world is going on here? Invalid move or oh okay, wait. It's coming back with the last move and putting that out. Okay, so if it's a valid move, it's stating what that is. Else it was saying G select the piece with the move string, but honestly that should be fine. So what did it change? Oh, the attempted move, but the attempted move is still algebraic notation, but it's using, okay. This isn't going to fix the issue. The issue's still present, right? So it should be an algebraic notation and not just from rank from file to rank to file. We need a function that converts properly to algebraic notation. For sending it to game.moveString. All right, let's see what that produces. To convert a move to algebraic notation, we need to consider the type of pieces being moved, any captures, any special moves, or casting pawns. Promotion. Here's a function that attempts to convert a move string to algebraic notation. You can use this function in the updated move method. Okay, perfect. Let's do that. Okay. I'm not going to validate this whole thing, but let's just go ahead and see what happens here. Right. So it's going to go ahead and create this. I probably okay, but like, okay, from file A from X from rank 1 to file, like, it's not all going to be A. Oh, I see. I'm an idiot. So it's taking the rune, which is an integer value starting at A, and then doing some maths to get the from file and from rank as certain values, and then it's converting those appropriately. Okay, let's let's go ahead and fix that, and then let's run it. Let's include that. Let's see what happens. Okay. Yeah, let's run. Let's go, baby. Okay. C33. Okay. Okay. What about just a D33? Okay. B33. Yes. Oh, sorry. I, right. So let's go ahead and provide that. So what's happening here is I think there's an extra value being added here in some cases. And so we can say is just ask looks like the new function to algebraic notation is not quite right. Maybe we should set up a test with some scenarios to validate this function. Let's see what happens. So I'm kind of leading it now into a set of tests here. So let's see what it says. Setting up a test is a great idea to ensure that two algebraic function works correctly. We can use Go's testing framework to create a test file. Okay, that's what we want to do. Test two algebraic notation. So given these particular positions, knight to C3, D3, B3. So these are actually the value Those are the valid moves. OBS with a notification. Why are you interrupting my stream here? But okay, so we can kind of see like this is actually right? So let's go ahead. I actually like this. Let's see if the framework can see. Yeah, let's see if we can do that, and then we can say like, okay, yes, let's run the test. Um, yes, fix the test. Yes. From int to string yields a string of one rune, not a string of digits. Fail. Go game. Go 49. Okay. Ah, right. Okay, cool. So now we've got some output. I'll say the test looks right. Please fix this function. All right, cool. So we're using this test to kind of iterate on the code now. So then instead of just replying on output or me actually like providing input, we're using this test as like a, hey, like here's some test cases. Looks like we're not actually correct here. Um, uh, did I just ask it and then not do? Oh, maybe I need to go ahead it. Okay. Yeah, I don't think I go ahead at it. Let's add that. Please fix. I like sometimes how it just like fixes it, and then other times like I gotta come back and like, okay, fix it. Um, yes. Slash code still not 100% correct. Please fix. We're just gonna keep iterating. Okay, okay, awesome. Um, our test is passed, but as we know, that doesn't always tell us everything, right? Um, let's see what we actually when we run the chess game now. Okay. Let's go straight for yes. Okay, we've got knight movage now. Can I move that over? No. Perfect. Can I move this over and it move a random piece? It does move a piece, which I'm not a big fan of, but it's not terrible. Okay. Let's go for something like this, then like this, then like this, then like this, actually this, then this, which would be a terrible move, but I'm doing it. And then we want to get our queen out there early. And so let's see if it'll let me do that. Okay, perfect. I can't, because that would put me in check. So that's actually what we're looking for here. But I could do this, and then I could do. Why can't I do that? QBX4. Why does that not work? Is it the wrong? No, it's definitely my turn. Okay. What else we got going on here? So QBX4. I think this is just QX. I don't think QBX4 is valid notation. Let me see what else I could do here. Let's play out some other pieces. BAX5. This is not a bishop, so why do we have B here? Shouldn't this be PAX5? But shouldn't it be PXA5? I think we're a little bit um we're a little off here. So let's see. Um can we add some tests that demonstrates proper chess notation or piece capture? So this is an interesting kind of approach here with the LLM where we're going kind of beyond um where instead of just relying on the LLM just to figure everything out, we're kind of segmenting down a specific ask case or a specific ask, and then we're iterating on that ask to solve a particular problem. Now, FX F is where the pawn would be, capture is the X, and then C3 would be the end position. But is that valid? I don't think you can capture from F to C with a pawn. Um, are these all valid captures? Knight D to C3 is, because D and C are next to each other. Knight to C3 is. Let's just say go ahead. Let's keep going here. Right, okay. So set piece. Okay. Well, so much for using the not nil library. So this leads us into an additional problem here where we need to be able to set up like a board from the beginning. And I think the way we do that, let's go back to the not nil library here. To set up an initial board here, let's just, yes, I'll say set up an initial board for testing. You need to use Venn notation and game chess.fen string. I think this should be enough. Let me see here. Fen. There we go. So it should be game.chess, game.fen. So let's see what he does with that. Have string want. What? Chess.fen. Oh, wait a second. I was wrong. So I gave you wrong information. Okay. Run it. Cannot use chess.fen value of type errors func chess.game from chess.new game. But it should be here. Let me see if I can figure it out. Please fix. Please fix. Oops. Please fi. Okay. Awesome. Perfect. We are cooking now. D3 want DX C3. Yes. Guess I should have clarified. The tests were good. It's the output that we're getting. So, want N capture C3. Want D capture C3. Tests look good, but two is still producing correct output. Okay. Let's see here. Still wrong. I think at this point we're just kind of playing a guessing game because again the LLM can't really logic its way through this. So I think it's just kind of basically make some randomized guesses and we're kind of stuck. So what should be happening is it's giving D3 and it's removing and adding the X in these different scenarios and we're not really getting to the output that we want. So I think in our next iteration here, we can go ahead and give it a leg up by just making our own changes and iterating on this and saying, okay, if we change these values, if we fix this particular scenario and kind of see how far we can get with the LLM and just kind of really treat it like pair programming. But you kind of get an idea here of what the limitations of coding with an LLM is. I'm wasting a lot more time right now kind of iterating through these tests and trying to determine like why the LLM isn't producing the output based on their responses. And this is a pretty frustrating loop to be in. I don't feel like I'm making much progress, although we did get some pretty far progress by changing the code a little bit ourselves. So we'll go through another iteration of that. We'll make some of our own changes the next time next Friday, and we'll kind of see what we get. The alternative here also is looking at some of the other LLMs. I really want to try 3.5 Sonnet in this particular scenario, particularly because if you look at Adder, it's pointing out that Claude 3.5 Sonnet is the way to go. For this session, oh man, I'm kind of curious. Give me 1 second. I think I can pull my dashboard over here to kind of end this out. Let's see how much money we spent today dorking around with ChatGPT. So if I go to the dashboard and I go to the usage and I look at it from a cost perspective, well, that's interesting. Okay. Today alone in this session, we spent about $2 total coding out our chess game. So what does our chess game look like? Let's see if it actually runs before we go. All right, so right now we've got a chessboard on the screen. We've got our pieces rendered. We're about 3 hours in, I think, total in development on this using LLM, so that's not terrible. We are utilizing some libraries, and we can make valid moves like that. We can make a valid move like this. We can then make a move like this. We can then make a move like this. And we can make a move like this. And we can make a move like this. And we can't make a move like that. So we've got basic chess piece validation in place that seems to be working when we provide proper algebraic notation. The problem that we have right now is we have a function called toAlgebraic notation that was provided by the LLM that attempts to take the inputs of moving a piece from this location to this location and then turning that into proper notation. The notation for this should be nxd5, not ndx5. It should be nxd5. So knight captures dx5, and I think that would be the shorthand notation. There's, I think, some additional rules, like if there's two knights that could possibly take it, that we indicate what the starting square is, and I think that's a longer form of the same algebraic notation. But the point is that we're not getting that proper notation out. So with that said, that'll be our focus next time, is to kind of refine that function. I have some plans here. So I do want to kind of iterate back to like the original like use case of what I was working on before I got on this tangent, which is my chess battler. And I want to kind of encourage everybody for is it this one? I don't even know anymore. But this is where we take a set of an LLM and fight them against each other. And so there we go. So in this case, this is ChatGPT versus ChatGPT. I could hook Sonnet up to this pretty easily, but this is kind of our end goal. And one of the things I want to do is I want to plug this in using what's it called? Using Stockfish, and do a live analysis of the choices that the LLM is making, because I feel like chess really kind of highlights its ability not only just to do random prediction, like if you kind of see back here, it's airing out and trying again and again, but rather you're going to see you're going to see that if there's any cognitive ability there instead of just pattern matching, right, and guessing. And what I want is I want to do have Stockfish. I want to provide an overlay where Stockfish is actually doing like a live analysis. And I think that's going to be pretty cool. I mean, that's another series, but I do kind of want to show you like where we're getting to. So like I was able to build this at this point much faster, or maybe about, we've got 1 more hour left with ChatGPT. So we'll see where we get to. But my time limit is about 4 hours for the LMs, but this is what we're getting to here. And so this is just LLM versus LM right now. You're seeing on the screen battling it out. And you can see here in the background, it's suggesting moves that aren't real moves, which tells you what? There is no deductive reasoning here. It's just token prediction based on state of the board, based on previous states that it's seen. And because it's not getting a value back, it's just kind of guessing over and over again. Now this is actually costing me a bit of money. Not a lot, but you know, if we look at my dashboard for today, what's it look like for the API? Let's just see what I just did there. I'm trying to see here if there's anything that's like worth worth talking about. I don't really want to show it on screen, but you know, different sets of usage. So we'll kind of keep iterating on this, but this has been fun for me. I plan to do this every Friday, so I'm going to keep kind of coming back to it, and we'll kind of see where we get to. Spend my lunch times talking to y'all. So it's great talking to you guys. If you have any questions or comments or things you want to see, or maybe it's just an edge case we haven't explored, or if you want to see what we can build with an LLM, if you want to see like what it would look like to build an API endpoint or something like that. You know, I really don't want to do anything front end, so I'm not going to do anything, you know, React or JavaScript or anything like that if I can help it. But even just from a backend perspective, can we create an API or service to do X, Y, and Z? We can kind of talk about what that looks like. I think those are simpler, easier problems to solve, whereas, you know, something like chess is a little bit more complex because you got mouse movements, keyboard movements, things like that. But again, it was great talking to y'all, and I'll talk to you next time, party people. All right, bye.